Okay, so hello YouTube. We are catching up with the advent of code because I skipped yesterday, so I have 2 days to do. I'll probably make 2 different videos anyway, but yeah, we need to catch up. So refresh. What? Okay. So yeah, day 12. Let's go. Your ferry made decent progress toward the island, but the storm came in faster than anyone expected. The ferry needs to take evasive actions. Unfortunately, the ship's navigation computer seems to be malfunctioning. Rather than giving a route directly to safety, it produced extremely circuitous instructions. When the captain uses the PA system, public address system, okay, like a loudspeaker, to ask if anybody can help, you quickly volunteer. The navigation instructions, your puzzle input, consists of a sequence of single character actions paired with integer input values. After staring at them for a few minutes, you work out what the problem means. So action N means move north by the given value, south do the same, east, west. Left means turn left by the given number of degrees. R means turn right by the given number of degrees. F means to move forward by the given value in the direction the ship is currently facing. The ship starts by facing east. Okay, so this way. Yes. Only the L and R actions change the direction the ship is facing. So if the ship is facing east and you have to move north 10, then the ship would move north 10 units, but it would still be facing east after the following action. Okay, after the action. Okay. So move forward 10, go north 3, move forward 7, right 90 degrees, forward 11. Okay, and then Manhattan distance, so we count the slots because it's a grid, and that's the total distance, 25 that we traveled. Figure out where the navigation instructions lead. What is the Manhattan distance between that location and the ship's starting position? Okay, oof. Let's see, is this hard? I have no idea. This doesn't seem hard, honestly. Last famous words, huh? So save directions.txt. Const data is embed file. Why does this make the at disappear? This kills me. LSP is messing around way too much. Directions.txt. Okay, so what do we want to do? We have the ship, and the ship has position, which is 2 coordinates, x and y. So do we need a struct for the ship? I don't think we do. So for now, let's just be lazy. So we have x position, which is a uSize equals 0. I'm assuming it's a uSize. The system could ask us to go into negative coordinates. Nothing would break. We just decided the 0 is where 0, 0 is where we start. So as long as it keeps us in a like bottom right quadrant, we are always positive, and that's fine. But we could go negative. I'll set our uSize for now. Or maybe I shouldn't. You know, we're gonna have subtractions, and I know subtractions are gonna be annoying. So you know what? Fuck it. Let's be iSize since the start. So var y is iSize. Then we have the direction. Var direction is what though? Direction is an enum. I think this we need to define. So const direction is a enum, and we can be facing north, Actually, there is no dot, right? It's like n, north, south, east, west. I'm not spending too much time on these things because I don't know yet how I'm going to represent the left and right rotations. And there are probably super smart ways of doing this. It's just that like that's not the kind of things that I do. I'm not like a game programmer. So I'll probably find an overly explicit kind of janky way of expressing this, but I mean, it could be worse. So we start facing east. So this is our starting point, our starting state. Then we need to parse the file. So var it equal std mem tokenize data on the new line. So while it.next, while we have something else, we have a line. And what do we do with this line? What do we do with this line? Let's see how it looks like. So we grab the first character and then we parse a number. So action equals line 0. And I'm gonna use characters. I'm not gonna parse those into an enum. I don't think there's any need for that. And then var num or arg, call it argument. It's the argument of the action. The argument is std.fmt.parseInt isize. I don't know, is this thing gonna give me negative numbers? Not really, but I don't know. Let's stay with the isize thing. Hopefully we don't get any problem. And then with lines starting from 1 until the end. Radix is then. Okay, so now we have the action in the arc. Now we need to map the action to a transformation in our both state. So switch action. And the cases are north. And if the case is north, what we do is if it's north, we do y. And here's the interesting thing. We need to have a proper way of, so where is the plus sign? Where is the minus sign? What do we do? Does it matter? I don't think it matters. It only matters that we are consistent. So let's say that we are want to be positive if we move right. Like we want to be positive if we move east and north, and negative going south and west. So this means that going north is going to be y plus arg without the semicolon. Then if it's east, it's x plus arg. If it's south, is y minus arg. If it's west, is x minus arg. If it's left, if it's left, what do we do if it's left? What do we do if it's left? So if it's left, we need to map the degrees also oh god, how bad are these degrees? So let me find left and right. 270, 90. Okay, they're all multiples of 90. So I guess we divide by 90 and we get here's what we can do. Let's sort these nicely. Let's sort these nicely. And so that we can play around with the enum cases, I think. I mean, I could do an explicit mapping and stuff. Let me think about it. So let's see if this numerical trick helps us. So we want east, then after east we have south, then after south we have west, then after west we have north. Like, well, this is one possible permutation of many, but the ordering at least is right. And with this, I can know, for example, that I take I don't know, let's call it ticks, and I take arg, I divide it by 90, and I know how many ticks I need to go. And what I can do is I take the current direction and I transform it to int. So enum to int of the current direction. Also, why is the LSP killing this? I don't know. So transform into an int. I add ticks. I add ticks, and I then modulo everything by 4, because we have 4 directions. Sorry, this parenthesis should go here. And then int to enum here, int value is this. So let's see if this makes sense. I take the original direction. I add how many ticks I need to do. Are these always positive? I think they're always positive. Yeah, I think these numbers are always positive. So I add how many steps we need to rotate, modulo 4. And this gives me the new direction. With right, it should be the same, except that the sign changes. So let me think about the sign for a moment. Actually, right is this. Left is minus. Is this what I want? Is this modulo what I want? I don't think this is the modulo that I want. I think it's at mod. Yeah, the problem is the negative stuff. Or you know, I could create like a left dir enum, do the same with the left enum, except that the sorting order is the inverse. Let's not do this stuff. Let's try to get this right. I think it's at mod. I think this should be fine. Honestly, I don't know. let's just consider it a starting point. And finally, we have forwards. For forwards, well, for forwards, we kind of want to do this. We want to say switch. This is ugly. Like, this could clearly have been like transformed a little bit, but whatever. Let's switch the current direction, and based on the current direction, we move. And here the cases are these basically. Actually, this should go back. I feel so bad that I don't have the indentation. Zig, please. Zig format file. What happens? No such file or directory is zig. Command zig fmt. Directory path. Why I don't have user local bin in my path? That's the problem. System preferences. Okay, wait, no. Blind preferences. Okay. Preferences, settings. Who told you? Path. Show full path. Shell environment true. Wait. I do have, like, I have zig in my normal terms. So what's up with you? Oh, that's it. Just shell environment true. File. Okay, maybe we can also do these package settings, zig settings. Yeah, you know what? Let's do this. Zig executable. User. Oh no. Users. Christoph. Documents. Zig. Build. Zig. This should be it. So let's see. Did we fix my stuff? Not really. Okay, whatever. Oh, we have compilation errors. Where? 929. Oh yeah, we're missing semicolons in here. Oh? No, we still don't. God damn it. So if it's F, if we are going north, yeah, it basically just moves us in whatever is our current direction. So this should be it, right? So we do this, and then after we are done, we just say, well, our current direction is print distance x plus y. What is the problem now? Expected semicolon. What? So enum to int direction minus ticks into enum. Oops. Wait, something doesn't match. Oh, that's it. Okay. It's probably not going to compile. I think I need to do mod also below, but let's see. Oh, cd. Zig build day 12. I expect Zig to complain about the other percentage thing. Switch must handle all possibilities. Right. Else, panic. Sad face. Next, error. Invalid operands by expression. I size and process int error. Yes. Missing a try. Next, undeclared identifier ticks. Yes. Next is division with I size and comp time int. Inside the integer, we use div trunc, div floor, div exact. Well, you know what? This can be a U size. Is this better for you? Incompatible type, I size and U size. God damn it. Okay, let's go back to I size and let's fix this then. Div exact. I'm expecting this to be a perfect division. Incompatible types U2 and I size. Type U2 here. Yeah, I mean, is this it? Expected type U2 found I size. That's a good point. No, that's not a good point. What makes you think? What makes you think that this is of type I size? What? Am I dumb? I think I'm dumb. Yeah, I think I'm just dumb. I think this should be. No, I don't think I'm dumb, but what's going on? Why is this not considered a... Why is this not considered a U2? I mean, it can only fluctuate between 0 and 3. So I wasn't dumb. It is a mod indeed. Do I really need to do this? Is this really it? Error, compatible ties, I size and void. You are right, because this is plus equal. These are all side effects. Plus equal, minus equal, minus equal. These are all side effects that we apply. Distance minus 508. That's kind of suspicious. Possible, but kind of suspicious. That is kind of suspicious. So, you know what we can do? Here's what we can do. Print state So we print the state. X, Y direction. And I think here we want add enum to int into enum. Maybe we don't want anything. Is this gonna print the enum nicely? Let's hope so. So we print the state and then we print the action. Action equals line. And then we print, and that's it. And we keep doing this. Errors expected something, got something else. What did you expect? Expected dot or what? Is this because of the direction? No. Expected type, write error or void, found type info, blah blah blah, format. Okay, it's my fault. Oh, I think it's this. I think it's because I'm using this outer thingy. Why am I using? Let's use square brackets. Okay, so let's see. Oh God, how many of these are there? Okay, so we start 0, 0 direction E. F41, X41, north 2, north 2. Yeah, but direction is always E. Left 270. So we're facing east. Left 270 is 90, 180, 270. So south. And yes, we are direction south now. S3 moves south 3. Oh, you know what? The number is not suspicious at all. I'm a moron. I forgot to do absolute stuff. I just need to make the numbers absolute. So this kind of looks reasonable. I think I got it right just by looking at, just by inspecting it a little bit. The problem is that I need to do, I don't know, do I have ABS? Please? Fabs. No. Oh God. X plus Y. You know what? Let's do X. Let's print both. I'll do this. I'll do the sum manually. Whatever. Minus. So they're both minuses. Okay, since they are both minuses, I can. We sum them, and then the final number should be 508. Then copy. Is this right? Yay! Right answer. So that wasn't too bad. Part 2. Before you can give the destination to the captain, you realize that the actual action meanings, again, were printed on the back of the instructions the whole time. Almost all the actions indicate how to move a waypoint, which is relative to the ship's position. Okay, I need to read this from the start again. Almost all the actions indicate how to move a waypoint which is relative to the ship's position. Action N means to move the waypoint north by the given value, south, east, west, means to rotate the waypoint around the ship left counterclockwise the given number of degrees. I'm not sure I understand this waypoint thing, so I think it'll get better explanation after. So anti-clockwise, clockwise, and then move forward to means to move forward to the waypoint a number of times equal to the given value. The waypoint starts 10 units east and 1 unit north relative to the ship. The waypoint is relative to the ship, that is, if the ship moves, the waypoint moves with it. So for example, using the instructions above, F10 moves the ship to the waypoint 10 times. Okay. So we have this other point. Now we are not moving the ship anymore, or we're not just moving the ship. We are moving this waypoint thing. And when we do F10, oh, I think I understand. Okay, so the waypoint is like a, it's like a vector. Yeah, it's like a vector, and every time we do, okay, now I get it. We're not moving the ship anymore. We are moving the vector, and now forward is a special action. It's the only one that doesn't move the waypoint. It doesn't change the vector, but it actually moves the ship. So we are basically using all these instructions to move this waypoint thing, and only F moves the ship now. So after these operations, the ship management distance for a starting point is going to be something different. Figure out where the navigation instructions actually lead. What is the management system between the location and the ship starting point? Between that location, okay, which is still going to be where the ship ends up being. Okay, so, whoa. So we have this information about the ship. Do we still care about this? Do we still care about this? Well, we do, but now it's not the ship anymore. Now it's the waypoint. So the waypoint has these. I think now we need structs. I think it's easier now if we have structs. I think it's definitely easier if we have structs. So, does the ship need to have a direction though? No, it doesn't matter anymore. The ship doesn't need to have a direction. The ship needs an X and Y. Because the current X and Y's become like magnitudes, I guess. Okay, this is interesting. This is an interesting exercise. How much do I want to avoid making complex stuff? Like, how much can I reuse of what I have right now? Let me think about it. So these X and Y stuff is always the same. Left and right changes the direction still in the same exact way. But now forward is not mutating X and Y anymore. Forward is mutating something else. Forward is mutating the ships. So let's do this. Var ship ship X is size 0. Var ship Y is size starting at 0. We know that X is what's the starting state of the waypoint? 10 units east, 1 unit north. So it's 10 and 1. These things keep modifying that as before. Yes. But now F is doing something different. We need to rewrite F completely. So what do we do in F? In F, we need to move the ship and the waypoint at the same time. So you know what? Wait. Can we really just do this? Well, no, it's not the same thing anymore with the arc. It's something different. It's okay. Wait a second. Maybe we can keep the switch because we're gonna use it later, but we need to do something more before. So let's keep this here. Holy cow! Why is this so ugly? I'm pretty sure I. Okay. So what is it that we do before? Now this means how many times the vector we need to move. So I guess we can do also the vectors is always relative to the boat. Yeah, it is a vector. So let's see some examples like with north. With everyone 10 units north to 10 units east and 4 units north of the ship. Yeah, so we don't have to do anything particular with that. You know, a very inefficient way of making this work, like to produce the minimum amount of changes, I think it's to do just y. So var I usize starts at 0. Hey com'è spaghetti? So while I is lower than arg, so we iterate I plus equals 1, and each loop we do this. So this is meant to be like the shortest, like without editing too much. How can we adapt this code to the new semantics? Like if we get f10, we know that we need to add the vector 10 times. So while we could do the switch out, like we could switch only once, since it's always the same direction that we're going to go, doesn't matter. But what we are going to do is change ships y, and we add to it y. Oh, wait a second. No, this switch can go because it doesn't matter. Actually, we don't even need a while. Okay, so I was doing the while just because I thought I would need it to reuse the switch, but no, it doesn't matter. So what we can do is just ship x is plus equals x multiplied by arg, and ships y is y plus y multiplied by arg. That's it. I think we are done. Now we need to make sure that these numbers now are still of the same sign. std math abs cast abs int x. Sorry, now it's ship x. Ship y. Okay, I'm a good boy. I'm doing the proper absolute math. So let me think again. This is a vector. So we keep applying these changes which are relative to the current ship position. And yeah, based on f, we apply that vector with the given magnitude. That's it. So are we good? No, compile error, of course. Invalid operands to binary expression. Oh, because there are, this stuff can fail. Try. invalid operands to binary expression, return type question mark. Oh, wait. Error union, error set, I size, and I size. What? 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 Oh, I know why. Because this try is binding after the sum. I think that's it. No, it's just that like this second try binds before this, but yeah, it's so I don't think I even need these diagnostics. YOLO. Is this right? Boom. Ah! Oh no, I was killed. It's not right first try. Why? What bug have I introduced with my latest changes? Oh no, so I guess our printing here is useful, but now we need to print more stuff. State is let's say vector state, and then vector and ship. And ship doesn't have a direction anymore. And you know, maybe is this ship direction that that I'm not thinking about, and that's what's killing me. It says the answer is too high. Attempt to do my research. Yeah, no. Let's see. Am I doing stupid things? So I know I could use more, but I like scrolling. So we start. The vector starts at x10, y1 direction east. Wait a second. Yeah, I think I misunderstood what I needed to do with the direction, because now that I think about it, this is telling. Oh yeah, you know what? Bye bye. Have a good dinner, Kumari. Okay, so this direction thing, I think I oversimplified the meaning of what the direction does. Action L means to rotate the waypoint around the ship left. The given number of degrees. Like rotating this waypoint around the ship is oh yeah, I'm such a moron. I'm such a complete moron. Yes. 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 Okay, now I understand. We have the vector, yes. But we can't just add it, because the vector has a direction, and we need to normalize x and y over the direction. That's so important. That's so important. So here's what we do. We need to switch, I guess. Do we switch these, or do we let me think about it. Yeah, let's just switch direction. So let's switch direction. Direction means that var norm x equals x, norm y equals y. So these are, we start with the original state that the vector has, but then we normalize these directions. So if the direction is east, if the final direction is east, we do nothing. If the direction that we need to apply this stuff is south, what does pointing south means? It means like these x and y, it's like left. But how can I say? South means this, basically. That norm x is minus y, while norm y is x. I'm very bad at explaining why I'm doing this transformation, but it's vectors that are changing. I don't know how to explain it. West means that the vector is actually pointing left, which means that what I saved in the x slot has to be negated, while what I saved in the y slot is unchanged. And then we have north. And north is, of course, similar to south, except the opposite. So in north, norm y is minus x, while norm x is y. No, I think I'm getting this. I think I'm getting this almost correct, but not quite, because it's x becomes y, and y becomes x here. This is not minus, and but here becomes negative. Okay. Well, I think we have it. Well, actually, this case is this case, kind of. I know it's simply rotating the vector towards the direction. Yeah, right, exactly. Because we have the problem that if we keep the direction as a separate property and we don't change signs here, then the math doesn't work out. Maybe I should not have been, let me think. I should not have been lazy and kept direction as a separate property. Maybe I should have baked in the direction in here and made this a proper vector. You know, when I was saying in the beginning, I'm not a game programmer, and actually game programmers probably know how to do this the right way. They probably know. And here I'm basically working around me not knowing how to make these things, write these things elegantly. So yeah, I'm just rotating the vector. I'm properly mapping this information here of where these two, like these are the two norms, right? These are the norm on one direction, norm in the other direction, but then everything shifts based on what this direction is. And yeah, that's what I'm doing here. And I think now this should be more correct. Expected token found symbol. Yes. Wait, is this number bigger or lower? Wait, is this giving me the same number, 443? Oh yes, because I need to then change this. Okay. Yes, smaller number 2, which seems compatible with what this was saying. So boom. Ouch! Answer is too high. What did I do wrong? So I think this code is correct. I don't think this code needs changing because that's what we were doing also before. What am I missing here? I think I did something wrong. Oh yeah, you know what? I think I'm a moron. I think I modified west instead of north. Yeah, like north and south should be symmetrical. I think while I was changing this stuff, I changed the wrong block. convinced that I was modifying something else. Okay, so let me check it again. East is right. East is right. South is swapping, right? Because if we rotate south, y becomes x, x becomes y. Yes, and the signs don't change. North is the same. Wait. Yeah, because the starting direction is east. Yes. So north has to be the opposite of this. It's the same transformation. You swap them, but the signs flip around. Now west. West is the x was actually negative, but the y is unchanged. Also, oh my god, look at this. There's another norm x. Yeah, I made a mess at copying this stuff. Holy shit. I was changing west thinking that I was changing north at one point. Let me double check. Is this correct? Yes, because you're flipping horizontally. So this says 50K. Your answer is too high. Yes. 50K seems... That's not the right answer. The answer is too high. Oh god. What did I do now? I think the W is wrong. The Y direction needs to be flipped. Okay. You're right, the Y direction needs to be flipped. Oh yeah, they are not crossing, but they are flipping. You know, I'm a moron. Thank you. And you know why I should have known this? Because they are all symmetrical, and so if this is east, then this is this has to be the opposite. Thank you. That's an embarrassing error. Finally. But I think I'm time limited now. What? Not even 6K? That's not the right answer. If you're stuck, you should be using the full input data. Because you guessed incorrectly 4 times in this puzzle, please wait 5 minutes before trying again. No! I think that was okay before. No, before it was worse. It was norm x and norm x 2 times. But I'm messing around with the... Why am I so bad? You know what? I think I was putting my fingers in the wrong direction. So let me try again with my fingers. So this is normality. South means that... Oh, okay. South means I'm an idiot. I was using my fingers the wrong way. South means that y becomes x, but x becomes minus y. That's 1. Then that's south. West means, oh god. West means that everything gets negated. Yes. You keep everything but the signs flip. North means that x, y. North means that x becomes positive y, and y becomes negative x. I think this is the right thing. I think this is the right combination. I don't know. I have to wait 5 minutes to try it, but I think I finally got the science right. And again, probably people that know how to do like the graphics programming are probably saying, "Oh, why is this idiot not getting it right first try?" It's like, I don't know, man. I have to wait. Yeah, too recently. 2 minutes and 41 seconds. We'll get there. 2 minutes to wait. Too many errors. What a shame. Well, I think this challenge was about, like, the question of this challenge was, is this guy, is the person doing the challenge, like doing the puzzle, going to be able to rotate a vector or not? And the answer was, nope. Sorry. Took me a while to get there. It seems about right to me now. Let's hope. Let's hope. Yep. Yeah, let's hope. 2 minutes and a half. How long? 1 minute 51 seconds. Ah, the agony. The agony. Stupid vectors. Hey, Mikdor. Let's see. Remaining 2 minutes. You know what? I could take this opportunity for a bathroom break, maybe? That might be a good idea. So I'll be back in 60 seconds. Actually, you know what? I'm gonna even run an ad. Evil. See you in a moment. Okay. Is this going to be the grand moment? The grand finale of this part? That's not the... Wait. Did I copy thing? Oh my god, how much? Okay, it's still 5 minutes. Oh, thank god it doesn't go up from there. Why? Okay. We should, I guess, debug our state stuff a bit and see what's going on. This is so sad. You know what? Here's what I'm gonna do. 2 and 1 pipe more. Try the example. Yeah, you're right. Maybe I should try the example, but let me just debug my stuff for a while, for a little bit. So, vector position 10. Like, I think I can see what's wrong here. What is going on? Oh no, yeah, because it's 41. Okay, right. So we are moving 410 and south 41. So that's fine. North 2 doesn't change our ship position, but moves the vector a bit more north. Left 270. Left 270 just changes the direction from east to south. Yes. Ship doesn't change position. South 3 changes this to 0. Okay. Forward 85. Forward 85. Why is forward 85? Oh, okay, right, because forward 85 with the vector pointing down means go down a lot. Since the y component is 0. Oh god, and I lost track of what I was doing. So 485 means go down a lot, since the y component is now pointing west. So we are not moving west at all, but we are moving south. I should name like x and y like south and east and south, so that it's more clear. Sorry, these should be east and south, so that it's more clear. Going down should produce negative y. Not in my case. I made going down positive. Or did I? I think you're right. Wait. Did I not make going down positive? Oh god. Was I inconsistent with that decision? I think you might be right. I don't remember what I did in the beginning. Going north is positive. Going south is negative. You're right. Which means that the starting stuff is wrong. As a starting point, the starting point is wrong because it's 1 unit north. So this should be -1. And then y is going south. And then I did this by thinking that south is positive, while south is negative. Fuck. God damn it. So, one bug fixed. Second bug is this stuff correct though? So my vector is like this. This is x, this is y. This is east, this is south. X is minus y. No, x is y. Y is minus x. Down is negative. This is south. North is x is minus y. Y is x. And this should be like this. This is the only one that, goddammit, should be okay, right? Yes, yes. Okay. I think we might have really debugged it for real this time. Last famous words. Oh man. Okay, let's see. If not is positivity, the starting point should be 1, not -1. Oh, am I messing around again? I think you're right. Yeah. I keep doing this. Okay, that you're right. That's correct. That wasn't wrong. I'm in my head. I have south, north, positive, negative, too confused. But I think this time I got this right. I don't know. Let's try. It's not the right answer either. Oh God. This is killing me. This is really killing me. So, how can we do this? X is 10. I think I was confused again while I was doing this then. Maybe. Okay, let's try again. East is okay. This is positive. Right is positive. Up is positive. South. X is Y. Y is X, but it's negative now because we're going down. West is... everything is negative. And we don't flip them. North... how do we represent north? I guess like this. North is... X becomes Y but negative, yes. Y becomes X. So this seems right to me. This seems right to me. North and east is plus. South and west is minus. I mean, I think it's obvious that this part that was working before here is okay. The problem is 100% in this stuff and maybe in the starting condition of X and Y. Do we know like maybe I should be better if I just threw away direction? No. No, I think it's useful. Otherwise, I would have to do transformations on all these cases. I could use, like, I could change these to apply the transformation to the vectors in place, but then I would have to do this and, man. Although, maybe that would work. Oh, that's terrible. Oh, wait, why am I getting a different number? Did I not run the code? Wait, did I not save? Have I tried 17207? No. Wait. Why is there a difference of 1? Oh my god, you know what? I might not have saved the change to -1. And that might have messed up my input. Oh god. How to save rules? Okay, let's try this other thing. Because everything seems in order to me. Starting conditions is correct. This part was working. This is the part that I messed with, and this is where I could do wrong stuff with the signs. This stuff down here is also reliable. I think it's like 100% in here. Well, let's wait this new minute and see what happens. Come on, I want to move to the next day. This is taking already too long, I think. 23 seconds left. Come on. 17207. That's not the right answer either. Okay, interesting. I think I'll do what Ronaldo was saying. Just try the code example. I think that might be best. Although, you know what? I suspect that this is too small to really show what I'm doing wrong. But hey, at this point, we need all the help that we can get. $286. So yeah, this is the small example is not stressing what we are doing wrong enough. So vector is 10, y, 1 direction east. This is a 0, 0, forward 10 means 110, yes. North 3 adds 4 to y, yes. Forward 7 moves 70 in the x direction, yes, moves 70 east, moves 4 north, well, 4 times 7 north, 28, yes. Right 90, direction changes, this doesn't change. Forward 11, oh, it doesn't print the last state of the ship. Let me also add this print the last state of the ship one final time. Action F11. So this is pointing south. Sorry, this is pointing south like this, which means that x it's minus 111 here. Yes, minus 111. And wait a second. So this vector is pointing south, which means that the end result is that x is 4 and y is minus 10. So minus 10 times 11 minus 110 minus plus 38 is, yeah, I guess 72. Yeah, sounds right. But then x is, sorry, then x is 4 times 11 is 44, and 170 plus 44 is 214. Yep. That is correct. Then there is one pesky transformation that I'm doing wrong. It's one of those annoying transformations that I'm doing wrong. East is right. West is right. It's one of these two. Or both. Maybe. No, south is correct though. We just did it. Oh, wait a second. No, okay, here I'm flipping x and y. Okay. And here I'm flipping x and y too. Y becomes I'm a moron. Y becomes X. How can I mess around this much with these things? Y becomes X. X becomes minus Y. And I guess these also get flipped around. Oh man, how can I mess with these things so much? Wait, this is now not giving the right answer anymore though for this simplified example. Oh damn. You know, I'm starting to think that I am too confused about this thing. I'm way too confused. I think the things that I'm doing here are wrong completely. I think my mental model is wrong at this point. It's not just making errors. So if the vector is the arrow just a fancier case without needing a break? Yes, the arrow indicates a case. There are no breaks because there is no fold through in switches here. And that's it. It's literally just for cases. Direction is an enum. So I'm basically just switching on the enum cases. That's what you're saying. And this is like an empty block where I don't do anything. Oh, wait, you know what I did? I think I know what I did. I did the north case and then I modified the south thing. Oh god. So north case is X is minus Y. Yes. And Y is X. Yes. South. Well, that's north. South is X is Y. Y is minus X. Yes. Okay. Yeah, I'm an idiot. I was looking at this and thinking that this was the north case, but it's not. Okay, so this is back to being, I don't know, to making sense to me. The problem is every time I build, I get this number, which is, according to the program, is not correct, right? According to the website. 17207 is wrong. Now, let's say that this is correct. This logic here is correct. Then what could be the problem? What could the problem be then? What could the problem be? I did this thing where I said now direction is something that applies to the waypoint and it doesn't apply to the ship itself anymore. I maybe should double check if that's the case. Although if I got this wrong like this, like if I had a big conceptual, if I missed something big conceptually like this, I think the sample case would have caught this. So yeah, this just moved the waypoint. This says this means to rotate the waypoint around the ship left counterclockwise the number of degrees. And these are the transformations that we are applying, yes. F means move forward to the waypoint a number of times equal to the given value. We are doing this also correctly. Waypoint starts 10 units east, 1 unit north relative to the ship. The waypoint is relative to the ship, that is, if the ship moves, the waypoint moves with it. So for example, F10 moves the ship to the waypoint 10 times, so 100 units east, 10 units north, leaving the ship at 110. The waypoint stays 10 units east and 1 unit north of the ship. Entry moves the waypoint units north to 10 units east, 4 units north of the ship. The ship remains where it is. F7 moves the ship 7 times. Blah blah blah. I can even check that like the intermediate states are the same. $110, then 170.38, 170.38, and then 214.72, 214.72. So I'm doing a lot of things right. And why am I getting that error? Let me just... Let me just copy this thing again. Yeah, 17.207. What am I doing wrong? Okay, you know what we can do? Let's go back to this. Let's make these... Let's add a step like left 180. Hey, NCTV. Thank you for a follow. But you know also what you can do? Let's change all this stuff to like right 90, left 180, right 180, left 360. Let's see what this does. So this changes just the direction though. Okay, so direction is east. Right 90 south, yes. Left 180 north, yes. Left 360. Left. Oh, I'm not printing the vector the last time because I never cared about the vector that much. Okay, that's fine. F1. So, right 90. F1. F1 when the direction is south. Moves Y down by 10. Sorry, it's like this. Moves south by 10. Moves right by 1. Yes. So this is correct. Then here, direction is north. Means direction north means up by 10, left by 1. Up by 10, left by 1. Yes. Direction south means down by 10, right by 1. Down by 10, right by 1. So these all seem right to me. What am I doing wrong? What am I doing wrong? I have an idea why I may be wrong. Is it okay to share with you? Sure, feel free. Yeah, don't worry. No spoilage. Actually, I wish I got this more easily because it's annoying being stuck. I was hoping to give a better show of, you know, getting through this stuff more easily. But I think I'm getting a lot of things right, and there is one dumb mistake somewhere And that's why some things are wrong. Just a very dumb mistake somewhere. I think the problem is not updating the waypoint vector after applying some rotations to it. Not updating the waypoint vector after applying some rotations to it. Updating it properly. Well, the idea is, in the current code, what I'm doing is I never update the vector directly, right? I never update it to, like, what's it called? What do you call them? Modules? Magnitudes? I change the direction in them. And, like, this code wasn't changed. This is the original code. When I normalize, like, when I like, this normalization is not meant to alter the state of the vector. It's just meant to interpret the state of the vector correctly, like from a numeric perspective, so that we do the math correctly. But then after we update the math correctly, so when we do the math correctly and update the ship X and Y position correctly, then we don't want to apply these changes to the vector. Or actually, sorry, technically speaking, I think that even if we were to apply these changes to the vector, the result would be unchanged. For example, if you turn it right 90 from the start position and then move east, the value of X doesn't update correctly. Okay, let's try. So we move it right 90, then we do east 1. And let's see what happens. I need to do also a forward 1 so that it prints the state of the vector. So this is the initial situation. Right 90 just changes the direction to south of K, but now this is how I should interpret the vector. East 1 East 1 East 1 changes East 1 changes X that way. East 1 changes X that way. Let me draw this. So this is the ship, and the vector originally is like 10 east, 1 north. So like the vector is like this, right? This is like 10. This is 1. Like the two components. Oh, thank you. That's what I was trying to say. So these are the two components. Then we rotate the vector 90 degrees down, which means that now this is the ship and this is the vector, right? 10 down, which is basically minus 10 for us, and 1 east. You might be onto something. We move the vector east by 1. Fuck. You might have found my problem. Yes. Moving this east by 1 means something like this. This becomes 2, and this says minus 10. This is like the boat again. And that's not what's happening here. So then the question is, why was my code okay earlier and wrong in this case? I think why was you're now with spaghetti? Nice. I think I might have I think Code Monk has solved my problem. Although that doesn't answer why was everything okay earlier? Why is this not okay now? And why is this not okay now? You know why? Because I think I understand what's going on. No, I don't. But so I'm starting to think that probably I didn't have an issue earlier because when we were moving the ship, both because you deviate from the correct answer when you apply forward after a rotation. Yeah. But why was this code correct for the ship case? I know, well, the ship wasn't a vector, so maybe that's the problem. By just the fact that the ship wasn't a vector, so... Okay, so you know what the solution is then. Instead of doing this... So, in other words, this idea of normalizing x and y is garbage. We should have never done it. And what we need to do is apply the transformations here. Every time we do left and right, we apply the math transformations, which I deleted, but I'm sure I'm gonna get them right first try here. No problem. Right? Direction. So we know what the new direction is. No, you know what? I need them. Please give them to me. Oh, God. So we switch direction and we just do this to x and y directly. Right. Now we're basically doing the same thing from before, except that this time we're making sure to actually save the change immediately in the vector. So now this says we rotate 90 degrees, and then moving east one does what we were looking for. Code Monk, you might have saved my ass. That seems a bit big though. I think we were told that the answer was smaller with smaller cases. Also, yeah, it's interesting. Yeah, you know what? Wait. Let's double check the freaking signs one last time. Oh god. Also, is it correct that we don't do any change if it's east? Wait a second. Yeah, wait a second. Yeah, no, we don't want that direction anymore. Yeah, I think I found a bug. Let me think about it. Yeah, so this is basically saying like this direction here just becomes something to interpret, but not the thing that we need to change. Right or wrong? Oh god, now I'm super confused. I don't know what's real anymore. Because earlier we were saying, well, we keep track of the direction and then we decide which case we are in based on this. So let me think about this a little more. So our case, our sample case was R90 E1. R90 E1. Then what should happen if we do R90 again and E1 again? What should happen? We are like this. 90 E1 should move like this. E1 should shorten the 10. Is this happening now or not? Ten 1. 10. Sorry, 1 minus 10. Yes. E1 2 minus 10. Yes. Rotate again. Minus 10 minus 2. Yes. E1 minus 9 minus 2. That is correct. That is indeed correct. That is indeed correct. YOLO. Oh, that's the right answer. Oh my god, finally. Thank you, Code Monk. I still, honestly though, am confused. So, super short retrospective before moving to the next exercise. Why was this okay the first time? Why was this okay when we were moving the ship? Because the semantic of moving the ship, because we were told that moving the ship with the northeast southwest thing would not change the direction, was like absolute stuff. But now when we're talking about vectors, I mean the first part of the problem, part 1. But now when we are Yes, yes, that's the answer. The answer is precisely that what was missing is what I misunderstood. In the part one of the exercise, you left and right would move the ship in its direction. But it doesn't matter the direction. If you say north 10, it means move the ship north 10, regardless of which direction the ship was facing. That was the semantics of the first half. In the second half, though, moving the vector more north or more south, it's dependent on what the direction of the vector is, which means that you have to keep it normalized. Otherwise, you won't be able to apply these changes this way. Otherwise, if I don't normalize it every single time, I would have in each of these to switch and decide what the proper way of adding everything together is. That is the piece that was missing in my brain. That was the precise problem. And for some reason, I was convinced that I could get away without having to renormalize the vector we can say renormalize the vector every single time, because I thought that I could just do it at the end, just before adding everything. But no, also the intermediate transformations require this, at least if you want to keep this as is. What can I say? The advent of code got me this time. That is indeed one thing that I did not have clear in my mind. The only thing that I can say in my defense is that I had never done much graphics programming and stuff like that, and I'm not used to thinking using vectors and spatial transformations this way. So in any case, that was fun, and I learned something. So I'll cut here the first recording. So YouTube, see you in the next puzzle, which I'm gonna solve just right now, actually. Yep.